Hi friends, welcome back to my course Power System Planning. We are discussing the third unit Power System Reliability. We have discussed the power system definition of power system reliability, planning criteria for generation, transmission and distribution, grid reliability. Today we will discuss the reliability target. We will take the quick review of the power system reliability is one of the major factors of planning, designing, operation and maintenance of electric power system. Failure in any part of the system can cause interruption of supply to end user. The grid reliability defines as a resilience as the ability to resist failure and rapidly recover from breakdown. The grid reliability are analyzed by two domains, resiliency and reliability domain. The reliability target. Reliability engineers are often called upon to make decisions on the product goal reliability. The question of how to meet this goal lead them to a reliability allocation problem. Which component needs to perform how reliably in order to meet the system reliability goal and assure an economically competitive development at the same time. A given product can be considered as a means of providing the functionally meeting of the customer's need. In these terms, the task of product development is to design the product so that it is able to perform its function reliably. However, not all components of a given system need to be equally reliable. Neither do they contribute to a given function equally, nor the function equally important. The omnipresent economical constraint in competitive environment require the development to allocate resource in line with customer requirement. Product reliability has repeatedly been specified as most important order-winning criteria for complex product. It seems reasonable to integrate the customer voice into the determination of the product of reliability target. As discussed, the process of determining system goal reliability and allocating subsystem reliability goals is currently a two-step process. First, the system goal is determined for which cost consideration. The system goal is then broken into goals for each subsystem. There are some different methods which are aimed at optimizing relationship between the cost and reliability levels. They help at defining economically sensibly reliability goals. Here we are discussing some method, Sally, Vanov, Churchman, Werner. The approach by Selinov considers the total cost of a technical product over its useful life and herein include investment cost, cost proportional to the operating time as well as cost increasing with operation time. Maintenance cost. This approach lacks of possibility to be used in early development stage as the too later cost cannot be defined until well into the useful life. Churchman takes into account initial cost as well as maintenance cost including interest. Here again the connection to reliability is only given through maintenance cost which have to be known. The reliability structure is not considered. The approach by Werner is based on the finding the cost optimal mean time between failures. Considered costs are product cost in general as well as maintenance cost. The formula includes cost dependent on reliability levels. The determination of some needed factor requires expert knowledge which limits its application. These are the methods which are used for the allocating subsystem reliability goals. There are two types of unweighted and weighted. And the unweighted method, the equal apportionment method, allocates subsystem reliability target, assume equal failure rates for each subsystem leading to given system reliability level. It is the most simple of all allocation methods. The system reliability need to be known. The failure rates of all components are assumed to be constant, and the system reliability structure to be either completely serially or completely parallel. Weighted method share the commonly that they are able to derive subsystem reliability target more accurately from the known system reliability level than the unweighted method. These factors stem from different scope and of consideration. The input information can be known as or assumed. Weighted methods are more realistic and therefore have higher practical relevance. Like the unweighted method, the weighted method have in common that the system reliability is known upfront based on which subsystem reliability levels are allocated. There are some approaches. Equal appointment, agree. In equal appointment, unweighted method, each subsystem is assigned with the same reliability level. Agree. The importance of the subsystem is the system is considered in terms of its contribution to the total time of application. Errinic. The new failure rates are calculated based on pre-knowledge and the assumption that their share toward the system reliability remains the same. Feasibility of objective. Empirically determined factor weigh the contribution of a subsystem to the system reliability. Carrying on. Empirically determined factor weigh the contribution of a subsystem to system reliability. Consideration the subsystem functional importance. Raka. Factors calculated based on the partially empirically determined parameter weigh the contribution of subsystem to a system reliability. Metas. Based on the monetary effort to improve existing subsystem reliability levels, new goal reliability levels are derived for each subsystem. In the next class, we will discuss the security requirement. Thank you.